Good morning, all. Welcome to another session for Azure Cloud Commanders. Today, we've got an amazing topic on Azure Kubernetes Service Security Best Practice. So looking forward to it. But first, before we get going, just some housekeeping. So this event is delivered on behalf of the Azure Cloud Commanders Learning Room. So it's within the Microsoft Tech community. Under Microsoft Learn, you can go down to groups, and then there's a bunch of groups by other managed by other community members. So there's some great ones on data and AI. There's some great ones on low code, and then the one I run is Azure Cloud Commanders, concentrating on just Azure in general, from administration through to app services, PaaS, and just anything through to administration through to architecture. So really great to have these sessions and share knowledge with the community. So feel free to join, add into the discussion, and keep an eye on events coming up. Just some notes that this session will be recorded for those who can't join it today. As attendees, your name is hidden, but be aware that if you do post questions, which is encouraged, your name will be shown. So the recording will be available on YouTube for later viewing for those who can't watch it. And obviously, if you found this recording later, you've obviously found it, but it will be on the Tech Community Events page as well as under the event. Just an inclusive session guideline, so just be welcoming, respectful to anyone in any of the chats anywhere. Just be considerate to kind people coming from different, diverse backgrounds and knowledge. So we're all here to learn, hopefully have fun at the end of the day. So just be human. So our speaker today is the amazing Santosh. I'll let Santosh introduce himself more, but I do appreciate you coming and getting up early to deliver this session for us. So thank you very much, Santosh, for coming and delivering a session on AKS today. So if you want, you can take it away.
Thanks, Luke. Thanks for having me here. Good morning, everyone. I'm sharing my screen. Are you able to see my screen?
Oh, it's probably because I've got my one up. So you can.
All good. Perfect. Thank you. Good morning, good afternoon, good morning, wherever you are based on. Thanks for setting up the session, Luke. Really appreciate it. Let's kick into my slide so that I can just introduce myself.
Awesome.
All good. Just quickly introducing about me. I'm Santosh Kumar Krishnan. I'm based out in Melbourne in Australia, basically from India, but calling Australia as a home for mostly 13 years now. And I'm holding MEP for Azure networking and cloud security. This time is my dual year, and this is my second year within MEP community. And I specialize in infrastructure and security, mainly focusing on public cloud, hybrid cloud, with over 18 years of experience. And other than technical side, you can find me in anywhere ground in close to Melbourne, or if not, I'll be spending some time to writing my blog. That's my website where I spend most of the time to have some of my fun trying out something, then I just exploring about it. In today's agenda, just give you a quick introduction about me, and I'll just run through about what is AKS. Then I'll kickstart in why do we need to securing containers, and how can we secure AKS clusters with private clusters and private integration with the VNet. And second thing is about your Microsoft different cloud with the different of our containers. You can do a image protection, runtime LLM scanning, all those things. Next is image and node protection. And last is about ingress and egress on your AKS. How do you protect that? And last will be a summarize on what we've done so far with the slides and covering up. Let's kickstart. Why do we need to securing containers? If you look at the normal workloads like infrastructure services or other time, it will be applications are more comparing with containers. Containers are like it's ephemeral environment where it is flexible. Containers are short-lived rather than the other workloads, and it can be resized rapidly. And 44% of containers lives less than 5 minutes. That's a stats has been released by Microsoft. And 50% of container images are getting replaced in a week or so because of the update of image or anything happening on the images. They are keep being updated. And software update requires creation as a once you create an image, there might be a patch or something created, so you have to keep updating your containers image. So that keeps the lifetime of the containers very short. The second thing is the demand of visibility and control. The containers traffic flow are very difficult to track with the traditional tools. So the containers runtime. Once you have your images running into the containers, you might have multiple vulnerabilities or patches. All those things can be happen. So you have to do scanning at the image level, then it's containers level. So that's a two-stage you have to do as part of containers. And the last one is expertise on the containers one. It's been quickly and rapidly evolving, and there is a shortage of skill as well. As you know, the AKS is a kind of a managed Kubernetes is coming from Azure. The common attack techniques are O permission. Sometimes the people doesn't know what permission has to be applied to a specific user or a group. So you have to make sure you are providing an exactly an role-based access control as part of your managing your AKS. Like you have to segregate your control plane and data plane separate, and you have to make sure the work nodes and the control plane access has been restricted. And exploit the vulnerable images. Sometimes the images might be outdated or insecure. You have to make sure the image has been scanned and it's getting regularly scanned, making sure it has been capturing all the vulnerabilities and making the images can lead to the breaches. The next one is you deploying the containers, right? The malicious containers can provide unauthorized access to the internet. If you're not sure about how long images have been scanned and what has been patched up, you have to make sure the images have been scanned and you're getting all the reports for your thing. And the last thing is the weakness in application code can be targeted by the attackers as malicious. It can be part of your vulnerability scanning, can be used with the DevOps and DevSecOps CI/CD pipelines as well. And the last one is the containers may escape isolation and compromise the host system, which can provide you bigger access to the attackers. So this is the threat landscape and how do you want to protect it so far. And let's see how the tools can help you to avoid the vulnerabilities and attackers on the malicious side. This is on the best practice on security recommendations: build, ship, deployment, runtime. During a build, use a trusted images. Make sure you scan your images and patch the vulnerabilities as soon as you got some reports and making sure it's been healthy. Then you ship it back to your images into the registry and do as images has been part of your secure registry with Azure Content Registry. Then just make an RBAC for your registry. This is just to build and ship. The third part is deployment, where your images will be deployed into an AKS and making sure how the AKS can be restricted with your API accesses and control plane and data plane access. And during the deployment time, you have to make sure you are blocking your vulnerable images. No need to have an image which has been having a vulnerability open source or something where it has an vulnerable patch or anything on the code that has to be blocked during a deployment. How do we do that? That can be explained as part of Microsoft Development for Containers that will help you to do that actually. The last time is runtime. Okay, you scanned your image is perfectly fine. You are in deployed mode. Once its image has been running on your containers, you have to make sure the containers is not getting multiple over the days. You will get multiple patches to be updated. How do we do that? How containers can be scanned regularly, even if it has been scanned in the image level, it has been deployed, it has been running now. You have to make sure it has been patched and it's been monitored regularly. That's where the runtime protection comes in as part of Microsoft Development for Containers. Let's quickly go through the couple of more slides and see how it can be useful. How it can be used. This slide just give you a high level on how AKS has been as part of managed control plane, where it's been managed by Azure. Only the customer VMs like the node, the worker pools, worker nodes on the other side, which will be helpful. AKS is a managed Kubernetes service that can use to deploy and manage your containers applications. You need just minimal container orchestration expertise to use AKS because the managed control plane takes out that will be managed by Azure, which provides you as a platform as a service that takes care of all your AKS control plane. So that way you just reduce the complexity and operational overhead of managing Kubernetes. So as part of today's agenda, how do we secure AKS? The first thing is securing control plane. As seen in the earlier image, the control plane is a kind of managed version of your AKS Kubernetes. So for organization with strictly requirements where the cluster has to be sensitive workloads or data are classified, the last thing you want is your control plane is being shouting in location across the public internet. You don't want that access to be happen on public internet. By default, AKS has that as a public internet. How do we do that? There are two options for you. One is you create an AKS private cluster, which comes with the Kubernetes API server lives entirely inside your Azure virtual network. In that way, you can reach your API servers or a control plane from application servers and the operators on the same private network. It is within the same VNet. And the second option is API server VNet integration. Let's see how we can do this. The first one is private AKS cluster. As I mentioned, organizations strictly requirements where they want to control their AKS control plane nodes to be within their virtual network. They want to keep everything within part of their virtual network communication. That way, the AKS private cluster helps you to keep that as simple. So by using private cluster, you can ensure the network traffic between your API server and your node pools or remains only in the private network. To do this, while you're creating an AKS, you have to make sure you select an option of your creating AKS clusters in the private. Once you do that, it establishes a private network. What happens is, even though its AKS is kind of the control plane is managed node, it keeps that control plane API server in a Azure resource group, and your node pool will be in a separate resource group which we manage it. And in the server and cluster node pool communicate with each other is through via Azure private link. That helps us to keep the API server in virtual network, and that private endpoint that's exposed on the subnet only to the AKS cluster. So that way, you are blocking any traffic which has been part of your public internet has been blocked, and it creates an FQDN, and it creates a private DNS entry to make sure the AKS also creates a public FQDN with the corresponding A record. In that way, the agent nodes use the private DNS to resolve the API server's IP address. So when we provision an AKS cluster, AKS by default creates a private FQDN with a private DNS zone and an additional public FQDN corresponding a record in Azure public DNS. So the agent node will use to only communicate via the private. So the traffic between your worker node and to the API or the control plane is purely within your virtual network. You control your traffic with your firewall or anything. So in that way, it keeps everything private, and any traffic which goes on public internet is being blocked. You can ask us, what are the use cases for a private AKS cluster? An AKS public cluster uses a public IP address of Kubernetes API, so that is directly accessible from the computer via the internet or anywhere. That would be also easier. But here, it just keeps everything in private. So therefore, organizations who required enforcing a security policy that requires all Kubernetes administrative traffic to be separated from the internet, AKS private cluster is a way to go forward. What's the second option? The AKS API server can be used as part of a VNet integration feature. The AKS API virtual network integration is a feature that projects AKS API server endpoint directly into a delegated subnet within your virtual network. The integration offers much more secure way and simplified network configuration. The difference between the AKS private cluster and AKS API VNet integration is the private cluster works with the Azure virtual private network and a private DNS. Here, you don't need a private DNS or private DNS zone at all. This just keeps you just create a dedicated subnet and just make your AKS API server has been delegated to that subnet. So that way, the traffic has been part of your API server directly into a dedicated subnet within the VNet. That's a difference. You don't need to have a routing complex methodology like you're bringing in private endpoint and bringing in your private DNS stuff into the picture. The API server VNet integration enables network communication between the API server and the cluster nodes without requiring a private link or a tunnel. The API server is available behind an internal load balancer with the virtual IP, which has been delegated into subnet, which has been created as part of that, and nodes are able to utilize that. By using this methodology, you can ensure the network traffic between the API server and your node pool remains only on the private network. API server integration can be utilized both public and private AKS cluster. Public access to the API server can be enabled or disabled after provisioning. This is another difference. In the private AKS cluster, you have to do that as part of your creation. But here it helps us even after you created it, you can able to convert this into a VNet integration feature. The agent nodes communicate directly via the private IP address of the API servers using the internal load balancer and bypassing the need of DNS resolution or the private endpoint setup. This is simplifying your private DNS setup, this option. So there are two different options. You can use it based on a requirement. You can choose this way. You are keeping out your control plane out of your public internet access and just keeping everything as more secure. Okay. The next section is more of Defender for Containers, which comes as part of Microsoft Defender for Cloud. This is one of my favorite topic out of the security thing. As the Defender for Cloud, as a security, Defender for Containers is a cloud-native solution to enhance monitoring, maintaining security of the containers workload and assets like clusters, nodes, your workloads, registries, images, and more of the node and protections. The Defender for Containers assists with you 4 core domain: security posture management, vulnerability assessment, and runtime threat protection for containers workload. The last one is the deployment and the monitoring. What happens with security posture management? It runs continuously, monitoring for the clouds and the APIs and the backend of your AKS clusters and resources and workloads to discover the cloud resources, provide a inventory, making sure inventories, resources, or capabilities detect misconfiguration, any mitigation guidelines to be provided, which can be asked for a risk assessment and empower the users to perform enhanced risk hunting as part of Defender for Cloud using Defender for Containers feature. Vulnerability assessment, as the name implies, it provides a performance of agentless vulnerability assessment of supported Kubernetes images and nodes and the clusters, and it can cover you for a daily. You can do a rescan, misconfiguration, and language pack, and you can just provide much more detailed information about all your vulnerabilities as part of your AKS cluster workloads. The third one is runtime threat protection. This is kind of a more advanced feature which provides a rich threat detection suite of Kubernetes clusters and nodes and suite for Kubernetes workloads powered by Microsoft Threat Intelligence in the backend. What happens here is once you scan your images and you deploy it, then you have to make sure that in container image or container workload which is running as part of the AKS clusters, your workloads has to be scanned in the real time to make sure is there any vulnerability detected as part of the container is running when the application is live and it has been running. The last one is deployment monitoring. It helps you to monitor the Kubernetes clusters for any missing sensors, provides any deployment for sensor-based capabilities, support for standard monitoring tools, and management of your resources. To enable this Defender for Containers as part of Microsoft Defender for Cloud, you have to enable this plan to specific cluster or a specific subscription. You have both option where you can just enable this for a specific subscription. In subscription level, the plans can be changed at subscription level. So that way it helps you to enable at the subscription any clusters or AKS workloads created as part of your subscription. The Microsoft Defender for Cloud with a specific plan of Defender for Containers has been enabled by default. With this level, what it helps you, what are the resources covers is like Kubernetes APS clusters, resources, workloads, and it helps you to scan your workloads on AKS. And second thing is it provides you with the registry access on the Azure Container Registry. And these services can be extended to other cloud, not only specific to Azure or AKS, it can be extended to AWS or GCP and your Azure local, which is Azure Arc. Any Kubernetes clusters running on Azure Arc, that can be extended as well for Defender for Containers. So it helps you to protect not only Azure, it's other clouds plus your on-prem services, which will be part of your Azure Arc. Let's go in detail and see how does it helps to protect with Microsoft Defender for Containers. It provides you the hardening information, like it enables to provide you information about AKS and other container platforms for security without disruption of workflow. And second thing is vulnerability management. It automatically scans the containers images for vulnerabilities for both during development as well as the runtime protection, which helps you the advanced threat protection. And the runtime protection is monitoring running containers for suspicious activities, or any providing alerts on potential threats. And as I mentioned earlier, it supports multi-cloud support. It just works with Azure AKS, AWS, GCP, and on-premises. When I say on-premise, you have to bring that as part of your Azure Arc, so that it helps you to get all your containers workload in a single dashboard within Microsoft different of a cloud or different of a containers as part of the plan. And it helps you to create an Azure policy enforcement, and it supports Azure policy. Like administrator can be able to define like certain images with specific vulnerabilities can be blocked during a deployment comes up, so that it helps you to have a healthy workload running in part of a AKS cluster. Administrator can define and enforce security policy for containers, helping to standardize the security measures and practices and best practices. And it is easy to set up. It is user-friendly interface, simplifying management across your multiple cloud workloads on AKS or the Kubernetes one. By integrating security with the DevOps lifecycle, it reduces the need of expensive remedial actions later, saving the ultimate cost. So if you combine this as part of your DevSecOps pipeline, that helps you to save much more money with the policy threatening on the images which is being part of your scanning, and blocks the images when it is being vulnerable to deploy in part of an AKS cluster. Let's see how it works out. When Defender for Cloud protects an AKS cluster, it automatically collects audit log data without agent. Its agent really helps through Azure infrastructure. To fully leverage Defender for containers, two key components are required. The first thing is the Defender for sensor. It's an agent deployed as a daemon set on each node. It uses technology to collect signals from the host and provides runtime protection. The sensor communicates with Azure Log Analytics Workspace, but does not store any audit log data. It is part of AKS security profile. The second thing is Azure policy for Kubernetes, which is nothing but a gatekeeper. As I mentioned earlier, this helps you to block any of your images, or you want to stop a deployment based on your scanning score as part of your deployment into AKS or any other cluster node which supports Defender for Cloud. There is a pod in the backend which extends a gatekeeper v3, which uses a webhook to enforce the policies on the containers consistently. It is deployed on AKS as an add-on, and it is installed on one node only. The configuration of the Defender sensor triggers the reconciliation process as part of Defender for Containers plan, which is helps you to have this policy enforced across your AKS cluster. This is extensively supported with AKS resources, and it can be extended for Amazon EKS and Google GKE for Kubernetes workloads other than Azure, and it can be expanded for AWS and GCP cloud. The container runtime protection, right? That's a another advantage. Like, say for example, you have your image, you're bringing a public image, you're scanning it, scan is perfectly fine, image is fine, you have some minor vulnerabilities, you're updating it and bringing it to your container registry. So the build is done, it's been shipped into your registry. Then the third part is deployment. When deployment is happening, you can enable Azure Defender for Cloud and making sure the policy has been checking off the resources which is coming into the deployment state. Once it's fine, it just makes sure the score is fine, there is no image vulnerable on these images, and making sure it's been deployed. Once it's been deployed, the last part is runtime. Runtime protection is where its image is running. Say for example, you brought it in first week of October, and it's been 2 weeks now, you found some vulnerable on that specific image which has been used 2 weeks ago. What happens is the runtime protection helps you to detect that specific vulnerable on that image. So how does the workflow happens is, once you detect the image or the container which is running with the vulnerability happening, the next thing you have to do is you have to bring a newly updated image, make sure it's scanned, make sure it's shipped into the container registry, and making sure you replace that container with the updated image. That's how it's immutable infrastructure. You have to just go and change your image from the older version to the new version, to making sure your containers has been healthy and doesn't have any vulnerable on part of their running time as well. even though it's scanned earlier, but it can be changing because it's a traditional world where the containers or any of the images can have some vulnerability detected. Probably once it's been scanned and been running, you have to make sure that runtime, that protection is enabled. That way, different of a container helps you to keep that healthy environment within AKS workloads. As I mentioned, it is agentless discovery for Kubernetes. When agentless discovery for Kubernetes extensions enable, which you have to enable as part of your setting, once you enable it, how does the workflow happen? So it creates a managed identity. Different of a cloud creates a managed identity in a customer subscription environment for CPSM for the containers. And the second thing is you have to assign a built-in role for Kubernetes agentless operator. It is assigned to this specific to this managed identity which you created in the first step at the subscription level, which includes permission for AKS, and the AKS resource can be accessed. The third thing is different of a cloud. AKS clusters discovers the AKS resources using API calls to making sure everything has been discovered, part of a subscription, which the managed identity has access within your subscription level. The last step is it just goes and creates a binding role to making sure the Kubernetes role to the managed identity, which has been created as part of the first one, providing permissions required for reading, granting the read permission, making sure within the cluster, within that subscription level. So that way, it just goes and manages. If you create any new AKS cluster as part of subscription, it just goes and detect and brings them as part of into a different of a cloud with a security posture, making sure all your resources of it can be AKS cluster, containerized, everything has been detected, and brings into your posture management to making sure everything has been secured and safe enough to use. As part of a different of cloud, there is AKS security dashboard, which has been using this AKS security dashboard that provides you different information about your AKS security capabilities. The AKS security dashboard is accessed from cluster resource pane. Just by selecting your AKS cluster, you can able to see this AKS security dashboard is being viewable in the settings, and that provides you security, visibility, and remediation information of your AKS. The dashboards provide you the security findings for the cluster and vulnerability misconfigurations. Each of this shows you summary and risk level of the list of recommendations as being part of your AKS cluster. This is in high level. How do you want to assessment through your software development lifecycle? Part of the containers, you have to do a CI/CD. You have to scan as part of your image vulnerabilities in the CI/CD pipeline level. Next is you have to scan it at the containers registry level, making sure the image has been pulled from public to your secure container registry. You have to make sure that image has been scanned in the container registry. Then it goes into the deployment mode, and you have to do a runtime protection as well as part of your cluster vulnerabilities to make sure everything is being captured from end to end. And this AKS security dashboard, what you spoke about, that provides you information about all your AKS clusters and configurations. Just ignore it has been previewed. It's kind of an older slide. I just want to give you an information about it is currently in a GA, so you can be able to make sure all the AKS security dashboard has been informationable for each of your AKS workloads and your AKS clusters. With that, we are moving to the next section of how do we assess your vulnerability containers image. What we spoke earlier about, which is a high level of on how does the workflow works out. Now I want to specifically focus on the image scanning or the containers image scanning. Different of a containers can perform agentless vulnerability assessment on images in a supported version. As I said, it's a supported container registry like Azure, AWS, and GCP. With all three public clouds have been supported. And vulnerability assessment of images in supported container registry is performed when registry access is enabled for different of a cloud for the security posture management. It supports scans vulnerabilities in OS installed on the packages and performs language support as well. And this agentless scanning for machines is enabled in different of a cloud security posture management. The scanning for the OS images, the containers performs a vulnerability assessment that has ability to scan or vulnerabilities in the package installed on the OS packages. It can be Linux or Windows operating system. Specific packages, Linux supports for language-specific packages, files, and the dependencies. And it can perform image scanning with, even if the container registry is enabled with the private link, it supports, it can provide scan of containers images via the Azure private links. That way, it keep the capability record only the trusted access to a private endpoint. So other thing is, once it's been scanned, it just helps you to provide your reporting like container vulnerability assessment powered by the Microsoft in the backend via the Defender vulnerability management. It provides the reports using following recommendations, and it provides you with the exemptions of recommendation for each of the vulnerability detected as part of the image. What is the process when a container images is being scanning is happening? The scan of image in container registry creates inventory of image, and it is vulnerabilities is each of the vulnerabilities being recommended is being reported and for it. When a new image is being pushed or imported into the container registry, it can be Azure or AWS or GCP, and this image is scanned within few hours. That's the first step. The second thing is the Defender for containers pulls the image from registry and runs it in an isolated sandbox. That's one of the biggest feature as part of Defender for containers. It just takes that image and pulls it into isolated sandbox within the Defender of vulnerability management as part of Azure environment. The scanner extracts all the list of known vulnerabilities, which has been part of the CVE score and across thing, and manages and gets all the information about it. The third thing is the Defender for cloud filters classifies the findings from the scanner. When the image is healthy, the Defender for cloud mark it as a healthy and making sure it can be shifted up. And Defender for cloud generates a security recommendation only for images that have issues or any vulnerabilities been found. Then it just needs to be resolved. By only notifying the customers or the users when there is a problem, Defender for cloud reduces potential of unwanted information sources. So in that way, whenever the image is been pushed into the container registry, it just goes and performs scan. Then it just pulls that image into a sandbox environment and making sure the scanning is performed. And if the resources or the images are healthy, it just marks and just goes. And the last stage is just providing if there is a vulnerability, then it provides a recommendation to how to be rectified, how to be fixed, to making sure that's been healthy. Yeah, this is the proposed vulnerability assessment scanning process. Once the image has been pushed or imported into container registry, the image is scanned within few hours. That's what I mentioned in the earlier slide. What happens, how frequently it just performs a rescan. The continuous rescan is required to ensure the image has been previously scanned for vulnerabilities and updated to make sure vulnerability has been created and be captured. Why we need to rescan? As I given an analogy earlier, like once you have image has been pushed and you've been scanned, making sure it's healthy, probably down the line the image might be vulnerable with specific it can be part of an OS or any package, some things get vulnerable, you have to get a next version or update that image. That's when the rescan makes very, very critical. The rescan is performed once a day. Images which has been pushed, which is less than 90 days, it just performs, the rescan is performed on once a day. Images pulled in the last 30 days, it can be performed the rescan every day. The image undergoes initial scan, and it provides you any recommendation which has been generated part of the image. Then the frequency, an image is scanned within 24 hours when it is pulled from the content registry. In some rare cases, the new image registry might take up to 24 hours. That's based on the each of the environment. In addition, the following images are scanned. In addition, the images are scanned every 24 hours to update the vulnerability recommendation. In an event of any new vulnerability is published, an image is pushed and imported within the content registry for last 90 days, or the image is pulled into the content registry for less than 30 days. So the continuous scans are scheduled to update the reports on the vulnerabilities, what is being captured as part of each of the image, which provides you information. The image pushed into the last 90 days are rescanned for the recent images. The images pulled in the last 30 days are rescanned daily, and that way the images are currently running on Kubernetes are rescanned. That's part of your runtime protection. And any of this recommendation is detected any vulnerability that goes into the vulnerability remediation reports. And if there is any new vulnerability detected, there will be a recommendation generated, and that will be provides you information how to fix it and what other vulnerabilities have been detected, and it just gives you the much detailed information with part of the Defender for cloud. We spoke about the images. Now on the cluster workloads, to make sure The scanning container is running on the cluster workload. That's a real-time or the runtime protection. The containers running in the cluster workload are scanned for vulnerabilities every 24 hours. That happens on every day. The scan is agnostic, running, containing images, source, registry, includes Kubernetes add-on, everything as part of your AKS cluster workload to make sure the relevant recommendations are generated for each of the vulnerable containers. The agentless scanning for the running containers performed when both the extension has to be enabled. It's been enabled. That provides you with a list of information of vulnerabilities detected. The scan depends on the registry supports as well as AKS environment, and it creates the containers and conditions whenever it's required. Say, for example, you have an image which has been running in containers, and if that image is become as part of your vulnerable, you have to make sure that image or the containers which is running to be detected as a vulnerable. That's been reported. The next action item is we have to work it out in a DevOps or CI/CD pipeline to making sure that image has been updated with the latest version. Then it's been imported into your containers running, which has been replaced with your older image to the new image. The next thing is the protection for the Kubernetes node. We spoke about the clusters, we spoke about the images, we spoke about container registry. The next thing is what happens to the nodes which has been running as part of your Kubernetes. The Kubernetes nodes are nothing but on Azure VMs, which have been created as part of the cloud environment, and it runs the Kubernetes services on top of it, making sure that the cluster controls the plane and the workload. The cluster node or manage a set of identical VMs. It can be operating systems of Linux or Windows versions, and that's why we have to make sure the node image is also being protected. How do we perform that with the different of our cloud? Is the different of our cloud recommendation is the support for protecting Kubernetes node upgrades version of it. Say, for example, first thing is we have to make sure it's been supported, the operating system has been captured as part of your VM work nodes, and Kubernetes nodes are kind of responsible for maintaining the Kubernetes nodes shared between the Kubernetes services and the customer, because the workloads are the data plane on the other side of the AKS has been created by the customer to make sure the Kubernetes service maintains the patching OS and software and unsupported images are running it, making sure it's been supported version and patches have been performed. When you create an AKS cluster, it has an option to make sure how frequent you want to patch the nodes which has been part of your AKS. You can select different options based on your environment or based on your settings required. And the customer is responsible for initially configuring Kubernetes node pool based on the requirements of the application, based on the requirement of your environment you want to set up, and upgrading the node pool VMs versions required to improve the security and support of the application running in the cluster. You have to match the version the support matrix to maintain that AKS nodes has been performed with the patching that has to be that has to make sure that provides you a much more information about your vulnerabilities. On the Kubernetes node protection, right, there are two options you can provide. One is a vulnerability assessment. The Kubernetes node, which has been running as part of your AKS cluster, has been scanned for the known vulnerabilities, making sure the operating systems or what are the software libraries running as part of your node pool, making sure it's been it's being scanned and provides you recommendation as part of your review to remediate if there is any vulnerabilities detected as part of the node VMs. Then you have to making sure that's been patched and that's been maintained with the Kubernetes supported matrix. The second thing is it can provide the malware detection. The Kubernetes nodes are scanned for any malware a security alert is generated and customer to review and remediate that specific node. The Kubernetes node protections are provided by taking a snapshot of the node pool disk. How it works is it just takes that node pool and taking a snapshot of the node pool disk for scanning, and it performs as agentless scanning architecture, which has been part of the different of our cloud protection. So that way you have to be customer has been responsible to making that Kubernetes node has been protected and it has been scanned for resources. And there is an option in AKS when you're creating it, you have to making sure how frequently you want to patch that node VMs as well. That comes to end of different of a cloud. That's a very big topic what we spoke about. The different of a cloud helps you to protect your images, container registries, workloads, and runtime protection as part of the Kubernetes clusters and the workloads running in. So that plays a major role as part of bringing your security into a bigger posture and making sure everything is being scanned and making sure it's been part of your securing from the build, deploy, ship, and to the runtime. So that's a 4 different stage. This is the last section. How do you want to protect your ingress and egress? Azure Application Gateway for Containers helps you to keep your applications on a layer 7. It protects you in the ingress solution. The older option is Azure Gateway for Ingress Controller, which has been the next the older version. Now AGIC still exists. The difference between Application Gateway for Containers and Azure Gateway for Ingress Controller is Azure Application Gateway for Containers supports Ingress and Gateway API as part of a Kubernetes workload. That's the biggest thing. And AGIC only supports Ingress, doesn't support Gateway. And there is a small time delay whenever you scale up and scale down your resources with AGIC, and AGC just is a real-time update. Like if you making sure you're updating or scaling up and scaling down your resources, AGIC can quickly adapt that and just brings the resources back into your services. So in that way, there is a real-time protection to you, a real-time update to you, and AGIC is slightly slower because of that. It just monitors the resources and making sure it just keeps it updated. So that way, I recommend to use Azure Application Gateway for Containers, which provides you a layer as a solution, and it can help you to enable WAF, and you can do a secure TLS end-to-end, and you can do MTLS as well as mutual TLS from end-to-end as well as. In addition, it supports the network policies to making sure you can have a Calio or Cilium, which has been supported as part of network policies that helps you to secure your resources. Azure Application Gateway for Containers architecture. It comes with 3 different components. First thing is the front end, which will be your application accessing the users accessing the front end. Second is association, where you have to making sure that application gateway for containers has been associated with a specific Azure virtual network, so that get resources from the thing. Last one is the container resources. That's a control plane. And Azure Application Gateway for Containers is a layer 7 load balancer, which provides dynamic traffic management. As the name implies, it's an extension of your application gateway dedicated for the containers workloads within AKS. So that way you can use the same architecture of application gateway across other Azure environment. You just want to imply that for your containers workloads. The other option is AGIC. The only difference is AGIC supports only Ingress. It doesn't support the gateway API as part of your Kubernetes resources. So making sure your choice between Ingress and the gateway API, you have to be very specific. If you're going for a gateway API, AGIC cannot be used. So I recommend to use Azure Application Gateway for Containers, which helps you to keep your resources on Ingress and gateway API. AGIC, on the other side, AGIC what happens is, it takes a couple of minutes or seconds, probably I think 30 to 40 seconds to update when there's a scale down or scale up of resources. That way it just been like there is a time lag. So that's another drawback on this side of the AGIC. So both similarly works on this way, and WAF you can be used WAF, and you can protect your layer 7 application on top of it. On the egress traffic, how do you want to do is avoid the default egresses. By default, AKS provides a hop out through cluster snap pool, which is easy ramp that quickly runs out of the ports and leaves you blind to who's taking to them. Instead of build a proper egress to all station, if you simply need a massive outbound capacity, then probably use Azure NAT Gateway that provides you a scalability, and your pods get predictable IP addresses. So least privileges, network policies, you can implement Azure Firewall or any other network virtual appliances that can be usable for part of your traffic detection when it goes on the outbound from your AKS. So these are the few things which you can use as part of egress traffic. And the last one is what we spoke about in high level is like the containers image and the control plane, objects, and the node protection. On the application side, you can use your layer 7 load balancer to making sure everything can be protected as part of your AKS workloads. And this gives you on high level what we spoke in today about the comprehensive security controls which can be used on AKS to making sure your AKS and the workloads can be much more protected. I think with that said, I come to an end. Thank you for your time, and I'll stop my session there and see is there any questions or anything. Look.
We'll just okay, that didn't quite Oh, that's a bit better. The transparent thing.
Okay.
Oh, wrong one. It's the Q&A. Just while we wait to see if there's any questions, what I wanted to also do for the community is I will just remove this one and this one, but every month there is an AKS community call. So the AKS product team will come and present to the community about what's happening in their roadmap. What are the latest things going on? So you can find that at AKS, AKS dash, it's aka.ms/AKS community calls. So
yes, I think that is specific for an APAC as well. There's a different time zone for APAC as well.
That's right. So aks.ms/AKS/community calls. I'll put it in the chat as well. But yeah, there is a call tomorrow actually. So it happens on the 4th Wednesday of every month within APAC. So New Zealand, it's about my calendar. In New Zealand, it's 6 to 7 tomorrow, but it's earlier for those in Australia, so that's 4 p.m. For America and Europe, it's the 3rd Wednesday of every month, so that will almost be in 2 days' time. But yeah, the AKS team are really good with actually having a lot of the information shared publicly, like the roadmap is on GitHub, for example. But I just wanted to share it because they're really invaluable resources. I don't know, Santosh, have you attended any of them?
Oh yes, yep. I have read a couple of few things, but it really helps to keep you updated as part of your what's coming on AKS. You can ask direct questions back to the product team and just say, "This is my feedback." Then, if you have an option, if you have something to present, they allow us to present as well. Like this is my recent thing came out. This is what tested out. This is how it works. You can just provide that feedback directly back to the product team as well. That way, it helps actually.
Yeah. You don't need to be an MVP. It's just
you don't need to be an MVP. Exactly, that's correct.
It's great. So I just thought I'll share that. Yeah,
that's a really good. It's a really good call.
But no, there's no questions coming through. I just want to say thank you for coming to present to us today.
Thanks for having me here.
Very interesting conversation. So thank you very much for coming up early. Hopefully you can get some of that great Melbourne coffee in you and have a productive day. But thank you for coming, presenting. It's such a complex subject because of the multi-layers, right? So you've got your containers, and then you've got all the systems that integrate with each other, and
yeah, that's correct. Thanks for having me, Luke. Thanks everyone. Have a nice time and catch you next time.
Awesome.
Have a nice day. Thanks. Bye.
Bye.